Hello everyone, in this video I'm going to try to bust a couple of myths surrounding the notion of primary colors in painting. If you've learned at school that red, yellow and blue are the true primary colors that you can mix all of the colors from, or if you think that you know better and you think that cyan, magenta and yellow are the only true primary colors, I hope that this video will help you rethink all of that and see a new perspective on the notion of primary color. So let's talk about this notion of primary color. According to the commonly accepted definition, colors are primary if they cannot be obtained by any mixing and if they allow to mix all the other colors. This is the definition you've probably learned at school, and I'm sure you were told that red, yellow and blue are the primary colors from which all of the colors are created. You know, primary colors mixed give secondary colors. Red and yellow make orange, red and blue make purple, and blue and yellow make green. From there, you mix every other color in existence. That's why they are called primary. They can create all the other colors and you can't obtain them by mixing. That's the commonly accepted definition, and it's still present in many serious art books and taught in many art institutions. But a closer look will show us that not everything is so simple. There are some problems with this notion. First of all, there seem to be two functional models at work. On the one hand, the cyan, magenta, yellow model used by printers, and on the other hand, the traditional red, yellow, blue model used by artists. If red, yellow, and blue are so unique and fundamental, how come printers don't use them? So basically, painters would have their own primary colors and engineers designing printers have different ones. Red, yellow, blue, or cyan, magenta, yellow. Which one is correct? Then, the second problem is that it's wrong to say that primary colors cannot be obtained by any mixing. For example, by using quinacridone rose and cadmium yellow, we can obtain a red as chromatic as the so-called primary red of the red, yellow, blue model. And by using phthalo blue and phthalo green, we can get a color that matches the cyan primary of the cyan, magenta, yellow model. Finally, the third problem is that the definition of any individual color in itself is ambiguous. From a physical point of view, there is no difference in nature from one color to another. So I can call magenta what you would call red, or call blue what you would call cyan. This is a confusion that has occurred in the history of color before. Before the words cyan and magenta were common knowledge, these colors were often referred to as blue and red, and their exact hue has changed significantly over time. But even today, who can really say what exactly is a magenta or a cyan? Similarly, for primary yellow, which is less debatable, you may find that the yellow I choose as a primary is too orange and prefer a greener yellow. In short, the infinity of shades makes the definition of primary color very difficult to grasp. So, in the end, what are the real primary colors? Red, yellow, blue, or cyan, magenta, and yellow?